Welcome back, everyone. I'm glad to see you at our new section dedicated to recursive methods. Now, this section is marked with a star for two reasons. One, this might be slightly challenging topic. We're gonna see an alternative to this topic. So if you find it utterly challenging, if you find it above your level of comprehension, you can skip it. It's optional. Or if you are behind other tasks, please focus on them. This is not going to be a priority. The second reason is, if as a developer you understand the recursion, then basically you have completed the whole development cycle. Recursion is one of the frequently asked interview questions. Especially these questions are asked by developers to see your comprehension, to see your understanding of stack memory, how it operates, etc. If you master this topic, then you can call yourself a developer and a magician. However, again, it is not that important, because anything that can be done by recursion can be done by loops, which is going to be our next section. So it might be a good idea for you to make a decision. Just I do recommend go through the materials, because it is not as tough as it seems. It is just basic principles taken to a next level, taken to a different parallel world. But again, it is optional. So having said all this, having talked about what the star stands for, let's look at what recursion is. Recursion means going around in circles, right? What it means by going around in circles is that recursion means you're going to recursive method calls itself. So in our content materials, you will see this small piece of code, a code snippet. As you see, the code's name, the method is called countdown. It has a one int parameter, and the method calls itself inside an else condition. So this is what recursion is, a method calling its own self. Without further ado, let's actually create a similar method that we will see we will understand how recursion works as we do so. So let's create a new package for our section. We're going to call this package section 3_5. And within this package, we're going to create a new class. We're going to call it a recursion introduction, recursion intro. Let's declare our main method and leave it be. And let's think about creating a simple method, right? A simple custom method, and let's have it return nothing at this stage. Public static void. We're gonna call it print n times, and we're gonna pass it int n. Okay. Now, what this method is going to do is, let's add our comments. This method is going to print a sample line n times. Okay, parameter n, right? So what we're going to do, we're going to print this statement, print line, printing, then let's call it printing plus n. So every time we call this method, for example, print n times, we're gonna call it 3 times, or let's call it 2 times. What it will do right now is it will print out printing n, right? Just one time, because we have not added anything to it. It's simple call, and it takes the n and prints it, printing 2. Now, let's add an if statement. We say if n is equal to 0, just do this printout. Right? Now, if I have 2 here, if I call this method, if I invoke this method with parameter equal to 2, it's not going to do anything, because this condition is going to be true only if n is equal to 0. But if I add 0 here, if I pass a value as 0, it will print out printing 0. Now, in the else condition, for the cases where n is not equal to 0, n, for example, is 2, I'm going to do this. I'm going to call this method, print n times. And I'm going to say, let's close this. I'm sorry, let's close this statement before we forget. And I'm going to say, instead of giving a specific number, I'm going to say, I'm going to assume that n is not equal to 1. It means n is something more than 1. I'm going to say, call this method and pass a value that is 1 less than whatever the user has passed in. For example, we're going to do print 1, right? So what will happen is this will come here. This 1 parameter will be passed in as an int, and it will be assigned to n. Is n equal to 0? No. Then what we will do, we'll say call the print n times with 1 minus 1, right? So it will be equal to 0 here. So this call will print out this, because it will create a new stack. It will create a new method. It will call this method, but with a 0 parameter, right? Parameter value equal to 0. So next time it calls it, this will print out. And then when it is done, it will get out. So when I run it, it just printed this. But we did not see how we got to this print, right? So let's actually add another print line here. And instead, actually, let's add another one print line before this what's the recursive call. We're gonna do this system out print line recursive call with n is equal to n minus 1. So we're gonna see that this print line is gonna serve the purpose. This print statement is gonna serve the purpose to show us that when n is not equal to 0, we're gonna get into else statement. It will print out that we're gonna call the recursive method with n's value being equal to whatever our call is going to be here, right? So let's run it. Now, since I passed 1, what will happen is 1 is not equal to 0, correct? So we jumped into else block and we started executing else statements. So first statement we executed was recursive call with n is equal to n minus 1, which is 1 minus 1 is 0. And we called this method, the same method but passed in 0. Since we passed in 0, when we made this call, it jumped in here with an if statement of a different method, and it printed out printing n. Afterwards, it comes back and moves to the next line, and there is nothing to execute here, there is nothing to execute in this method, and it gets out. What happens if we do print n times 2? It shows that recursive call with m is equal to 1, recursive call with n is equal to 0, printing 0. So we printed 2 times the recursive. So we made 2 times recursive calls. We came here, is n equal to 0? No, n is equal to 2. In that case, I'm going to print out, I'm going to call this method recursively and say that n is equal to 2 minus 1, which is 1 now. And I print this out, then I call it, and within this method, within this call, the first call, I'm going to again come here and say that is n equal to 0? No, n is equal to 1, because 2 minus 1 is equal to 1, right? So I'm going to come here, print it, saying that I'm making another recursive call with n being equal to 0. And when n is equal to 0, we come up inside the new method and say is n equal to 0? Yes, we print it. We get out of the statement and we get out of the method, and that's it. And to show you how we get out of the method, we're gonna print here getting out of recursion where n is equal to n. So we will see which recursion this is getting out of. Run. See? So recursive methods are interesting from the perspective that they populate the stack, then start destroying this. I mean, then they start getting destroyed. So recursive methods are first in, last out, follow first in, last out principles. So this is recursion 1. This is recursion with n is equal to 0. So this recursion here occurred, was destroyed, and got to the end of the statement at the end. This recursion got 1 before end. And the printing 0 recursion, the innermost recursion, got executed and terminated right away. So exercise with recursive methods. Stay tuned. In the next video, we have attached a presentation for you to go through the stack diagrams and how stack diagrams are being created in recursive methods. So in the next video, we will go through this presentation together, and we'll try to add some visual aids to it. Okay, thank you very much for your time, and I will see you in our next video.